Hello everyone, I am Dr. Sirajul Akfazi. I welcome you in my YouTube channel. Today in this video, I am going to talk about surface tension. You know my friends, I have already uploaded 2 videos on basic concept of liquid in chemistry. So before seeing this video, you have to watch my previous 2 videos. Then this topic will be very clear to you. Let us start learning of surface tension of liquid. You know, this is the gamma, and we are representing this physical phenomenon of liquid with the gamma. Surface tension, how you will define? You know my friends, surface tension is defined as the force that causes the molecules on the surface of a liquid to be pushed together and form a layer. The force that causes the molecules on the surface of a liquid to be pushed together and form a layer. You can see here a beaker contains liquid, and now you can see this pictorial diagram. Surface molecules pulled inward. Surface molecules pulled inward. You have to understand this point. And interior molecules pulled equally in all directions. Interior molecules you can imagine here, here, any places. This is only for understanding. So interior molecules pulled equally in all directions. You can see this direction, but here you can see only inward, not upward. So surface molecules pulled inward and interior molecules pulled equally in all directions. Then you can see the surface tension is caused by the net inward pull. This is your surface molecules and this is your interior molecules. So surface tension is caused by the net inward pull on the surface molecules. You can see. Now you can imagine here the inward forces on the surface molecules minimize the surface area and form a drop. Minimize the surface area and form a drop. So if you understand this physical phenomenon, then you have to learn about the effect of temperature on surface tension. You know my friends, surface tension decreases with increase in temperature. Surface tension decreases with increase in temperature. So if you look at water, ethyl alcohol, methyl alcohol, acetone, toluene and benzene. Now look at here 20 degrees Celsius, their surface tension is like this. At 40 degrees Celsius, now it decreases. At 80 degrees Celsius, further decreases. And 60 degrees and 80 degrees Celsius, you can see the further decreases. It means what? It means surface tension decreases with increase in temperature. Look it here, at here, surface tension phenomenon in this pictorial diagram. This is due to surface tension. Now, how you will determine the surface tension? First, capillary rise method. Capillary rise method. What is the meaning of capillary? There is a tube that is known as capillary. I will show you. And then you have to understand the capillary functions. So upward force, you have to write like this formula. Upward force, this upward force in capillary, and where r is the radius of the capillary. For most liquid, theta is essential 0 and cos theta is equal to 1. Then the upward force reduced to this parameter 2 pi r ground. Now the downward force on the liquid column is due to its weight, which is mass into gravity. Thus, this formula, downward force formula, is like this. So where d is the density of liquids. You know, upward force is equal to downward force. So this is equal to this, and gamma is equal to finally dynes in centimeter. Each term you have to remember and practice it. What is the meaning of HR, what is meaning of dg, and why it is 2 here. So in order to know the value of gamma, the value of H is found with the help of a traveling microscope and in density with a picnometers. Now each parameter you have to calculate with the help of the instruments. This H found with the help of traveling microscope. You will calculate the microscope, and this is your capillary, and capillary you have here liquids in this container. Then you imagine situation like this. Now these situations create here mathematics, gamma cos theta, gamma sin theta, here 2 pi r gamma cos theta, that force is upward force, and downward force, this h dg by r square. So rise of liquid in a capillary tube, surface tension acts along tangent to the meniscus, and its vertical component is gamma cos theta, and upward force you have seen, and downward force. Now my friends, one solved example. You can see a capillary tube of internal diameter, you have the R value, is dipped into a liquid whose density, now you have the density. The liquid rises in this capillary to a height, now you have H. Calculate the surface tension. You have to calculate the gamma. You know the G value. So apply this formula, gamma HRDG to dynes per centimeter. H you know, R radius you know, D density of liquid, if water then you know, and G acceleration due to gravity in centimeter. So substitute the value from the above examples, you can see, then you will get, in relations we have this. So the answer should be 25.69%, and thus the surface tension of liquid is this. So above informations you have to collect it, understand it, put it in the formula and do the calculations. Now another examples how you will calculate the H. So how height will rise in a plant of the capillaries. So this diameter and density of you have here, and surface tension now you have, G you have, then you have to height you have to calculate with the help of this formula. So put it in the formula and do the calculations. My friends, another method we have to calculate the surface tension, draw formation method and ring attachment method. Draw formations method, you can see here a draw forming from a tube of radius r. A draw forming from a tube of radius r. So surface tension acts at outer circumferences. This is the 2r, this is the inward mg. Another ring attachment method, fixed end torsion wire, fixed circular scale, knob carrying a pointer attached to the torsions wire, platinum ring, watch glass containing liquids, watch glass. So 9 tensiometers, do 9 centimeters. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching, and wait for the next method, how you will determine the surface tension. And I would suggest you, please go to the previous 2 video and then watch this video, and then wait for the next 2 video for the major chemistry semester 2. Thanks for watching.